I'm going to go through, a bit of that, bit of this. So first thing I want to ask is, can you put your hand up if this formula is familiar to you? As in, you know how to use it, you're like pretty happy with this. Okay? I'm going to very quickly do an example of this one, just purely because it is such an odd formula to randomly throw out during the gradient of straight lines. So I'm going to ask, let's just do one quick example, and then let's go straight into it. So let's say I have y equals to 3x plus 2. If I told you to find the angle at which the line that y equals 3x plus 2 graphs, angle that makes with the x, a positive direction of the x-axis, what would you need to do? What does the m stand for? Gradient, easy. So the gradient is this one. All I do is I substitute that. So I'm going to write 3 instead of m. No, yes, that's correct. 3 instead of m, we'll write 3 equals to tan theta. And how do I find the value of the angle? Did you guys do inverse tan in year 10, year 9? Easy. So I'm going to write tan inverse, or tan to the power negative 1. And then I'm going to write 3, which equals to theta. Can someone put that in the calculator for me? Equals 71.6 degrees. Awesome. So that, to give a picture, what it tells me is that if I have that line, axis here, and I draw that line, now obviously that line is not going to be perfect. I'm just trying to, do an example. That angle here that it makes with the positive direction of the axis is going to be 71.6 degrees. Okay. Sometimes you end up with a negative value, in which case you might have a line that is like this, but in this case we've got a positive one. What if I'm going the opposite direction? What if I'm saying, all right, let's go with tan theta, or let's say the angle equals to 45 degrees. Okay? In which case I'm thinking, how do I find the gradient of my line, which gives me 45 degrees? Once again, I substitute into the formula. I go m equals to tan, and I start writing theta, I write 45 degrees. Can anyone tell me what's tan 45 degrees? Yes.
1.
Easy. 1. M equals to 1. Okay? So that's saying that if I have a line that goes straight through here, then that angle there is 45 degrees. Does that make sense? Yeah? Sweet. I'm going to move on to today's exercise, being exercise 2D from memory. Let me just double check. Exercise 2D as per our lesson plan, and then later I'm going to go through exercise 2E. Yes?
The line is negative. Do you still use?
New topic is exercise 2D on graphing straight lines on page 51, I believe. Yeah, page 51. If you still copy down stuff from earlier, that's alright, just keep copying that down. Now, graphing straight lines is pretty straightforward, no pun intended. A lot of it is just revision of stuff that you guys already did last year. Typically looking at, well, if I'm presented with an equation, can I draw a line? If I'm presented with 2 points, can I draw a line? Now, intuitively, we know that a straight line goes through an infinite number of points. So if I have, let's say, this axis here and my line goes here, I have an infinite number of points along this line. So no matter what value, is that coming up on the screen? Not really. If I have certain coordinate that goes onto that line, screen's gone. If I just use 2 points on a line and I just plot those lines, those points in and then connect the dots, that's essentially going to give me that straight line. So it doesn't actually matter what coordinates I have along those lines, as long as I have 2 coordinates. And when we look into calculus later on in the year, we'll be looking at, well, it doesn't matter how far away those points are. But look, for now, let's just try and draw our straight lines. So if I was to try and graph the graph of 2x plus 4y equals to 10, what's the easiest way of approaching this question? What do you always do if I said graph a line, find the y-intercepts? X and y, easy, find your axis-intercepts. It's the easiest value to put in. All I have to do is substitute y for 0, x for 0, right? Let's start by looking for x-intercept, in which case I let y equals 0. Does that seem familiar to you guys? Easy. So x-intercept gives me 2x plus 4 bracket 0 equals 10. So I'm just substituting y equals 0, and that gives me 2x equals 10, and thus x equals 5. Now, what is the actual coordinate? It's not x equals 5. That is not a coordinate. 5, 0. Easy. If you wrote x equals 5, that's actually a line itself. So now let's do the other side. I've got my x-intercept. Let's now do our y-intercept. So I'm going to do y-intercept where x equals 0. Pretty straightforward. I'm just letting the other value equal to 0. I get 2 bracket 0 plus 4y equals to 10. In which case I get 4y equals to 10, and thus y equals to 5 over 2 or 2.5. Either one's fine with you guys. All right, am I done? No, I have to actually graph it, right? So I'm going to go ahead and do a very poor rendition of a Cartesian plane. Lovely. Okay, so from here, I know that my points are 5, 0, and 0, 5 over 2. Remember that second coordinate is our y value. I'm going to put those points in. Let's say that that is there. That's, oops, let's use blue for that one actually, just to minimize confusion. 5, 0 right there. And then I've got my other coordinate, which is 0, 5 over 2. So let's say that's right there. 0, 5 over 2. All you have to do there is grab your ruler and then connect the dots. That's it. Any questions? Pretty straightforward? No? So that's when we're presented with an equation in this form. Sometimes you're presented with an equation in your gradient intercept form, in which case you get something like y equals to 3x plus 4, let's say. Okay? This one is actually, you can take a different approach. Now, instead of looking at it as substitute x and y equals 0, you can do that. Don't get me wrong, you can do that. But this method may prove to be a little bit easier in the future. So we know that 4 is our y-intercept. Am I talking too fast? No? Let's say that 4 is our y-intercept. So I'm going to go ahead and draw my graph again. All right, lovely. So I've got my 4, which is over here, let's say. 0, 4, or you can just write 4, given this intercept. So I've got 4. What does the gradient tell me? What is the gradient? No, that's in general. What's the concept? What is the gradient? What does that mean? Steepness. Lovely. So you guys remember the rise of a run? Easy. So if it rises 3, it runs 1, right? Because remember, in this case, m equals to 3. So it means that however much it goes up, divided by however much it goes across, gives me 1. So if it goes up 6, what's the value I have to divide it by to get to 3? 2. Easy. So let's say I'm going up by 3, just to make things simple. I go up by 3. What's that axis, y value there? 7. Easy. And if I go up by 3, I have to go across by 1 because the gradient is 3. So if I go across by 1, what is my x value? 1. So now this point is 1, 7. Once again, I connect the dots. I said I connect the dots. There we go. And that's our line there. So all you need is 2 points. If you can find them by finding x and y intercepts, do that. If you can find them by just using y-intercept and using a gradient to move up, do that as well. Okay? This exercise is a lot easier than the other ones, purely because it's just it's less application and more so just finding the values. So please give this exercise a go, and then afterwards we're going to go into parallel and perpendicular lines, which is a little bit more application based. Any questions? No?